All right, we have this integral antiderivative of sine of theta cosine theta d theta. We're going to do this one by letting u equal sine of theta, and therefore du is equal to cosine of theta d theta. And so applying the substitution, we get integral of u du. So that's clearly 1/2 u squared plus c, which is 1/2 of sine squared theta plus c. And so that looks like the answer. However, we could do this another way. We could do integral of sine of theta cosine of theta d theta. And an alternate approach would be to let u equal cosine of theta, and therefore du would be equal to negative sine theta d theta. So looking at the antiderivative, I put a minus sign in front. I've got cosine of theta times negative sine of theta d theta. So that can be written as negative integral of u du. So that's minus 1/2 u squared plus c. Using this u, we get minus 1/2 cosine squared theta plus c. All right, and if that wasn't confusing enough, there's a third way to do the problem. Integral of sine of theta cosine of theta d theta. This is equal to 1/2 integral of 2 times sine of theta cosine of theta d theta. And hopefully this should ring a bell from pre-calculus. 2 times sine of theta times cosine of theta is the trig identity for sine of 2 theta. That's a double angle identity for sine. Okay, and for this, we'll apply the substitution. So we have that u is equal to 2 theta. And so du is equal to 2 d theta. Applying the substitution, we get 1/2 times an additional 1/2, 2 sine of 2 theta d theta. So that becomes 1/4 times the antiderivative of sine of u du for minus 1/4 cosine of u plus c for minus 1/4 cosine of 2 theta plus c. So we have 3 answers. We have this answer, 1/2 cosine squared theta plus c. We have this answer, negative 1/2 cosine squared theta plus c. And we have this third answer, negative 1/4 cosine 2 theta plus c. Okay, now why in the world do we get 3 different answers? Well, the answer, of course, is that they're not different. They're actually the same. So let me write this in purple why they're the same. If I come back here, sine squared theta, we have a trig identity that says that's the same thing as 1 minus cosine squared theta plus c. And so I can write that as 1/2 minus 1/2 cosine squared theta plus c. Okay, an arbitrary constant plus 1/2 is an arbitrary constant. So being sloppy with the arbitrary constant, we can write that as minus 1/2 cosine squared theta plus c, and that matches the answer that I see here. So this answer and this answer look different, but they're really the same thing because of the trig identity. Likewise down here, negative 1/4 cosine 2 theta. Again, there's a trig identity. The trig identity goes like this. I can write this as 1 plus cosine squared theta. Sorry, I got it backwards. Cosine 2 theta can be written as 2 cosine squared theta minus 1 plus c. So cosine of 2 theta is cosine squared theta minus 1. That's a trig identity. That's one of the 3 double angle identities for cosine. Multiplying out, this is equal to minus 1/2 cosine squared theta plus 1/4 plus the constant. And once again, 1/4 plus an arbitrary constant is an arbitrary constant. And so this reduces to what I had up here. So these 3 different answers, 1/2 sine squared theta plus c, negative 1/2 cosine squared theta plus c, and a negative 1/4 cosine 2 theta plus c, those are all look different, but they're actually the same because of trig identities and by shifting the arbitrary constant.